Hi, in this video we're going to do a depreciation problem. And the problem asks, assume you purchased a new computer for $1,299 and that computer depreciates in value at a rate of 10% per year. Find the value of the computer after you've had it for just 3 years. So we're going to go ahead and use this formula up here, V equals P times 1 minus R to the T power. This is the formula we are going to use for all depreciation problems. Built into the formula, there's the minus sign, which accounts for the depreciation rate that's happening here. So computers don't hold their value. They usually go down in value as new computers come out. So we're going to take this formula and fill in the things that we know. So we don't know the depreciated value. That's our question mark, but we do know the original price of the item is $12.99. We do know the rate of depreciation is 10%, but we want to write that as a decimal, 0.10, and then the time in years is going to be 3. So I'm going to fill these in with what I know. $12.99 times 1 minus 0.10 raised to the t, raised to the third. We do know t is the third power. Order of operations tells us we need to start inside of parentheses as our first step. So I'm going to do that very first. We're going to have V equals the $12.99 multiplied by 0.90 to the third power. Next thing we want to do, following order of operations, is we raise bases to the powers. We want to do our exponents as our next step. So in our calculator, we're going to type in the 0.9 raised to the third power, and that's going to give us the $12.99 multiplied by 0.729. Now, if this goes out to more decimal places, you'd want to write out probably at least 5 or 6 decimal places so that your final answer can be really accurate. You never want to round too early. Finally, order of operations tells us we're ready to multiply. And so we will, in our calculator, multiply that 0.729 with $12.99. And after 3 years, assuming it's probably still in good condition, our computer would be worth $946.971. Since money is, rounded to 2 decimal places, we'd want to do that here, and our final answer would be $946.97.